question here is, those manufacturing needs to become internet compatible or perish. Wow, that's a huge challenge for Vincent Champain. Vincent, you're operation director for GE Corporate France, and you're about to tell us more about what we can sum up in, like what, Industry 4.0?
Yeah. So is it working?
It's working.
Yes. Hi, everybody. So what I wanted to present you this morning is what we are doing in manufacturing, because, and I think Bruno mentioned it, we see lots of connected things, or we hear about a lot of connected things, but there is probably a much bigger revolution happening in the plants, in the places. You don't see them, but if you look at the number, and I will show them to you, you'll see that it's much bigger. That's what happens in the B2C scope. So just a few words about GE. So GE is the biggest digital industrial company in the world. So we're operating in a lot of different businesses like power and water, healthcare, oil and gas, aviation, energy management, transportation, and we created a few months ago a new business called GE Digital. The goal of GE Digital will be both to accelerate the digitalization of all our businesses and also to sell a new industrial platform called Predix, which is a set of software components which will help any industrial company, even possibly our competitors, to accelerate the way they include digitalization into their industrial process. So first, why all of this happened? Because you'll see that many of the technology that were presented this morning, or that I will present, I mean, the idea of this technology have been floating around since decades. I mean, you've heard engineers talking about predictive maintenance 30 years ago. Why is it happening now? It's happening now because the cost of sensing, of analyzing, of storing information is now close to zero. And that's a good news for all of the companies which need to include this technology into their process. So just two examples. The first one, that's the cost of storing data. So this one is just what you can get yourself. You take your credit card, and if you go to Amazon Web Services, the cost will be, okay, between 1 and 2 cents per gigabyte to store data. That's zero. Other thing you can do, and any of you can do it by yourself, if you go to Alibaba.com and you look for ESP8266, you'll get this for $1.8. This is a system on a chip, so you just need to plug a battery on this, and what it does, it has 100 MIPS, 4 megabytes of data. You can just plug it into your computer with a simple USB dongle, and you program it, and after it, you plug a battery to this, a sensor, and it can analyze data, store data, and transmit data through Wi-Fi. It costs this for you if you just want to have this in your mailbox tomorrow, maybe 2 weeks, because it comes from China. So if you're in the industrial business, usually what you are selling, it's, I mean, a gas turbine that costs 50 million, plus all the services, or the smallest part we're selling might be maybe an ultrasound device for a few $100K. So this is zero compared to the cost, which means that anything you can do intellectually using technology, using data, I mean, the price of the component is no more the barrier. The barrier is either your imagination, the way you can lead your customers into the path of modernizing themselves. And Qualcomm and Legrand talked about the hospital. If you look in France, I mean, lots of things are to be done to ensure that our clients have the same level of maturity that our engineers have, and it can take some time. But the limit is not the components. The limit is how fast you can find components on the market, combine them, and bring new value to your customers. So first thing was about hardware. The other very important part of this strategy is what we'll be selling externally beginning of next year, is what we call Predix. Predix is the counterpart of all you've seen on a hardware for software. Because today, if you want to take the chip or the storage solution I just presented, then you have to program something. And if you look how we are doing software in the industrial world, you'll see that usually you have lots of verticals, none of them having usually a very big scale. And what is needed is a way to ensure first you can securely and quickly develop thousands of applications, not only a few tens, and also how you can multiply the possibility of any engineer to do micro apps, meaning if they have an idea of making things more efficient or giving a new service, they should be able to transform this into something that works very easily. And what Predix is about is exactly about this. It's a platform which allows you to do automatically 95% or 90% of what you need to do something working in the initial world with the highest possible level of security. Everybody heard about the stuckness virus in the nuclear plants a year ago. Everybody heard about the Jeep Cherokee hacking last summer. Nobody wants this for his products. So if you want to accelerate and demultiply the number of applications of software running, you really need something that is very ruggedized and on which you can develop without taking any risk for your company. That's what Predix is about. So if you look at the numbers, and of course, we can discuss this, and that might be one question, but you see, if you compare the value of the consumer internet, which is everybody sees, every minister will talk about, what will you see on the newspaper, and if you compare it to the industrial internet, what is happening in the plant, in the power plant, what is happening in automating process, you see that more than twice of the value is really in this hidden part. That's very important, and I'm happy that EDAT, invited me to talk about it, and I saw that in the discussion, it is really something that is growing, not only at GE, any other company. So if you take today the biggest exporter of intelligent connected device in France, it's Safran. They're exporting $1 billion of highly manufactured plane engine, which are filled with sensors, with intelligence. The last signal we got from the Malaysian plane, which was lost 1 year ago, was signals sent by the sensor of the plane engine. It's everywhere, but you don't see it. Well, some of you do, but most of us don't see it in the day-to-day life. What we do with this is, a few technology. So finding value with big data, introducing a new technology brick into an existing set is usually a bit like finding a needle of value in a haystack of data, une aiguille de valeur dans une botte de données. It's very difficult, and really it's all about how you can dig into your haystack at the lowest possible cost. And what you do is usually you have a few very clear value levers. Some technology that you know that if you use it, you'll have a proved value. And you have also tens, hundreds of things that you try. Sometimes it works, sometimes it doesn't work. And if you want to really make a profit out of it, you really need a technology which helps you to make this test with the lowest possible cost. And that's what about taking low-cost components of the market is about, because you invest the lowest possible amount, you only take existing components, some of them you use them in a pay-as-you-use scheme, so you only pay when you use them, and you can make mistakes, and mistakes don't cost you a lot. Talking about the few clear value levers that work most of the time, first of them is preventive maintenance. So that's a very old idea. 20 years ago, I met the CIO of Areva, and he told me that 20 years ago they bought an IT company exactly for this. Of course, the technology and the costs were not in such situation that it was possible to apply it. But what it's about being able to forecast, to know that an equipment will fail before it fails. You can imagine for a plane engine what it means, of course. That's really something that is valued by a customer and by anybody, but it also can be very interesting even for less critical piece of equipment. How it works, you take data flowing out of an equipment, and using this data in a multidimensional space, you can see relations that are true all the time. And if at some point you see a deviation for the relation, you know that there is something wrong. So you can identify that your equipment is about to fail before you have any issue, which means that you can save lots of money because you don't have to check an equipment, going with a yearly or a monthly visit. And it also means that you can planify your maintenance cycle exactly at the time that it costs you the less. For airline, it's really a huge source of value. Why? Because you can do the maintenance at a time where they don't use the plane, and so you don't have a lost cost of blocking the plane to do a maintenance cycle where you could use it to make flights and earn money. So the other part is something also which is very common. It's about planning or scheduling, so that's really the basics of managing a plan efficiently. What's new about this is first that you can have what you do when you're managing plant efficiency usually is you optimize usually mainly locally your process. What you can do now is that you have a lot of data, you have data from all different parts of the process, and you can really optimize at the total plant level all your operation. And with this, you can really make new things. For example, if you're managing a power plant, you can optimize what happens inside the power plants based on the evolution or the forecasted evolution of the market price of electricity. And you can suck additional value from the fact that you really do things according to the consequences in terms of market value of your production you have. So it's what we do in power plant, but you also can do the same thing in agro industry and many industry in which you have a lot of variation regarding the cost of your output. And the last one, and it's about fleet and logistics optimization. That's also a very old idea. I mean, if you look at in books, you've been talking about this for years, but with sensors, if you place GPS chips in cars or in trucks, you can really do lots of new things. And the good news is that most of the things don't cost you so much to do. And in many cases, you can have, 1 year or even several months payoff. So you invest very little, and then you really start making a profit very quickly. I'm not sure I used my time. Huh?
Well, actually, you can conclude if you want, and then we'll have some questions with Ambroise.
So, just before going to the question, maybe as a conclusion, and really, if you see in the history of technology how and when you see an acceleration of technology, you see an acceleration of technology when you are in a situation where it starts to being very easy to play and to combine technology bricks into making new technology or injecting this technology into your process. And that's exactly what is happening today for the industrial world. And you could say, okay, internet, the beginning of internet, it was in the 60s, in the 70s. Internet didn't go nowhere big before you had HTML language in the 90s. When you have a language that enabled, all of us using this technology in a simple way. And that's exactly what is happening today for the industrial world, and I would say it's very, very exciting.
Thank you so much. Factories of the future. Ambroise, do you have any additional question to tackle Industry 4.0?
Okay, so thank you very much, Vincent, and it's interesting to see how G, which is a very I wouldn't say old, but with a long history, is completely transforming itself. So my question is more about the services that you presented. It seems a lot of them are maybe internal, improving your internal processes, but are some of these new services that you would provide to your customers or to new companies outside of G?
Yeah. So, yeah, most of this started internally, and even Predict started internally. And I think it has sometimes it has been, a problem for G to be such a big conglomerate, because you see financial analysts and they ask you, okay, what's the common point between making a toaster and a plane engine? And it's not easy to answer this question. It was really a luck, because having all these different verticals, we saw what was happening on digital in all different industries, and I would say we were almost the only one. And that's really what pushed us to a very architectured way to introduce digital into our technology. So first step was really to do our homework and to digitize ourselves. And it's still a process going on, of course. What we're doing now is, talking to customer, and it depends a lot on maturity. If you take airlines, they are very rational, they are very competitive business. Any possible way to add hundreds of % of productivity, they take it, and they ask for it. To the contrary, if you go to a hospital, especially in France, usually it's a client which are, and I think it's a good thing, care a lot about patient care. The financial part is not always the biggest concern, so we have to adapt our proposition to them, and it presents it in a very different way. So now I would say, depending on what industry you're looking at, we are in very different sequence. In aviation, highest possible, it's shared value creation, very high level, and any possible idea is coming very, very quickly into the hand of the client. If you look, to hospital, I would say it's a longer path, and it depends a lot from the structure and from the country. You take, for example, in the US, usually you have HMOs, which are in the same time payer, health care provider, and this one understand quite quickly any possible technology can bring them. And you only make one tender. If you go to France, you have 3,600 different hospitals. It's a different culture, so you have a different proposition, more oriented on care and a bit less on financial, because that's not the main concern for our clients.
Okay. And what about fleet management? You mentioned that.
Fleet management, the business was part of our capital business, which is being sold.
Okay.
So I would say that's not where we'll invest today.
Thank you very much, gentlemen. Thank you again for the smart manufacturing expose. And you all know that the Internet of Things and the servicisation of this industry won't be anything without networks, of course. So